Welcome to my Statistics 1 students. This course is going to be a maintenance course, which means it will supplement what you're doing in class. So my goal with the maintenance course is to go over topics that we've already done in class each week. So you'll have some homework questions to work on, and then these videos will come out showing you how I would approach the questions. And the goal, I guess, is to keep fresh in your minds the topics that we've already covered, so that there's not a whole lot of cramming that needs to be done at the end of the year. So I think consistent work throughout the year will be really beneficial to you. So the first key indicator for our course is representation of data. So this first question actually is a past exam question, I think. So the lengths of diagonals in meters of the 9 most popular flat screen TVs and the 9 most popular conventional TVs are shown below. So we've got flat screen on the first row and the conventional next, and we've got to do a back-to-back stem and leaf diagram. Now I think this was worth 4 marks, and there's a number of things that you need to do. So first of all, we'll set this out. We'll have flat here, flat screen, excuse my writing, and then we'll have the conventional on this side. And then what we'll do in the middle is we'll have this sort of thing like this. Okay. Okay. And let's have a look. What are we going from? The smallest number is I think it's a 0.65. I think it's a 0.65. Okay. So we have a 6, and then we go 7, 8, 9, 10, and then I guess we'll just do some lines this way. Obviously you're going to have a ruler, which will make it a bit easier. And like this. Beautiful. Now one of the things that you always need to do is to have a key, so we won't forget about that. We'll do that at the end. Now let's do the the flat screen first. So what have we got for the flat screen? The smallest we have, I think, is a 0.76. So so we go down to here and we'll put a 6 there. And then we've got a 8.5 and an 8.9. So I'll do those ones next. 8.5, 8.9. And you want to make sure that you have them in order. 8.5, 8.9. Then we've got 9.1, 9.2, 9.4, and 6. So 1, 2, 4, 6. So 1, 2, 4, 6. And then we've got 1.04 and 1.07. So we'll go 4 and 7. So that's it, group. Now let's move over to the other side. We're going to do the conventionals. And you can see in the 6s we've got 3. So 6, 5, 6, 7, 6, 9. So 5. Oh, that's pretty badly done, isn't it? 5, 7, 9. And then the next ones we've got 7s. We've got 1, 4, 5, 7. 1, 4, 5, 7. And then we've got an 8, 5 and an 8, 6. So 5 and a 6 here. I think we are done. Now, so that's looking pretty good. They have to be in order. Now, the key. So over here we'll write the key, and we could just take, say, something like this bit here, right? We could go 7, and we've got this, right? On one side we've got a 6, the other side we've got a 1, and then we'll write means 0.85 flat screen and 0.8 sorry, what am I doing? Yeah, means 0.76 flat screen, and we better put our units in meters, or 0.71 meters conventional. So in order to get the marks, you really have to have the key. Okay, you need a key. And yeah, make sure you don't forget that. Okay, so moving on. This next one, we've got to find the median in the interquartile range. So key thing here is we've got 9. So the median will be the middle number, which is the 5th number. So we go up in order. So we've got, on the left hand side, we've got 6, and then 5, then 9, then 1. So it's this one is our median. What are we doing? We're meant to be doing the conventional one. So let's ignore that. So there's 9. So it's 5, 7, 9, 1. And I think this is our middle number because we've got 4 on either side of it. So it should be 0.74. So 0.74 meters conventional. Median. That's our middle number. And now we want to find the interquartile range. So to find the interquartile range, we need to first of all find the upper quartile and the lower quartile. So looking at the upper bit, you'll see that we've got 4. So we've got 1, 2, 3, 4, and the middle number is going to be halfway between this one, the 0.77, and the 0.85. So that is a distance of 8. So halfway between them would be, I think, 0.81. And then we can do the lower quartile. So the LQ is going to be, you've got these 4 numbers, 1, 2, 3, 4, and you want halfway between these two here. So the lower quartile should be 0.68. So with this one, you see how we're ignoring the median, and we just look at the bottom 4 and find the middle of that for the lower quartile, and we ignore the median to find the middle of the upper quartile. Yeah. Okay, so I think those are our two values there. So the IQR, or the interquartile range, is equal to it's the distance between the upper quartile and the lower quartile. So we should do this. What does that give us? Is it 13? 0.13, sorry. 0.13 meters. Okay, now for the next part, we've got to find the mean and the standard deviation of the lengths of the diagonals for of the 9 flat screen TVs. Okay, so how are we going to do this? Well, you actually can input the data in your calculator, and I'll probably show you that in class. But it's also good to know how to do this by hand using the formula. So what I think we'll do is we'll use this formula here. So let's have a look at our values and see if we can do that. Okay, so the sum of x squared divided by n minus the mean squared, and then we're going to take the square root of that. Okay, so what we're going to do is we're going to have on the top, we're going to have 0.76 squared plus 0.85 squared plus 0.89 squared plus 0.91 squared plus 0.92 squared plus 0.94 squared. I'm going to move this over a bit. Nope, that's not helping me at all, is it really? Okay, plus 0.96 squared plus plus what's that, 1.04 squared plus 1.07 squared. Okay, now that whole thing, we'll find out what that is equal to. So let's do that. Okay, so let's grab the old calculator. What do we get? 0.76 squared plus 0.85 squared plus 0.89 squared plus 0.92 squared plus 0.94 squared plus 0.96 squared plus 1.04 squared plus 1.07 squared. Okay, so I don't know if this is right or not, but I'm just getting 7.7984 at this point. And now the number of items of data that we have is n, so we've got 9, and we need to find the mean. So to find the mean, I'm just going to add all of these up. Okay, so I'll do that now. 0.76 plus 0.85 plus 0.89 plus 0.91 plus 0.92 plus 0.94 plus 0.96 plus 1.04 plus 1.07, and then I'm going to divide that by 9 to find the mean, which you should know from IG. So for that, let's change over to this. So the mean, we represent it like that, x with that line over it, equals 0.926 recurring. Okay, and now we're ready to chuck that into our calculators. So we're going to do the standard deviation should be equal to the square root of 7.7984 all over 9, because n is 9 pieces of data, subtract, and then we're going to go 0.926 recurring squared. And if we chuck that into our calculator, well, we'll see what we get. See if I've made a big boo-boo on the way. 7.7984 over 9. I'm going to square root the answer. And I'm getting 0.0 to 3 significant figures. I'm getting 0.0882, which I think is the right answer. So you can see it's quite a complicated and long process, and it's good that your calculator has a shortcut for this, but it's good for you to know how to do it by hand like this. Okay, alright, now let's have a look. We're going to do the same. We've got to find the mean of this data, so the sum of the data divided by the number of items of data. So let's have a look. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 pieces of data. Okay. And then I'm just going to add them all up on the calculator. So 23 plus 27 plus 33 plus 36 plus 43 plus 44 plus 47 plus, now there's 350, so that's 150. I should have added that. 51, 2 60s, which is 120, 61, 63, 69, 70, 76, 79, 80, 81, 84, 87, 93. Now, if I haven't made any errors, that should be 1,417. So hopefully I got that right. Let me know in the comments if I made a mistake. Divide that by 24 and you get your mean. Now, my mean is 59.0 to 3 significant figures. Obviously, when I go to calculate my standard deviation in the next step, I'm going to use my unrounded answer, which is this fraction here. Okay, so for the standard deviation is equal to the square root of the sum of all the values of x squared over the number of items of data minus the mean squared. Okay, now I'm going to square each of these numbers here and add them. Okay, so essentially it'll be 23 squared plus 27 squared plus 33 squared plus 36 squared plus 43 squared plus 44 squared plus 47 squared plus 50 squared plus 50 squared plus 50 squared plus 51 squared plus 60 squared plus 60 squared and 61 squared plus 63 squared. Oh, I've run out of room. I'll just add those ones up first. Just keep an eye on your calculator. 61 I got up to. Plus 63 squared plus 69 squared plus 70 squared plus 76 squared plus 79 squared plus 80 squared plus 81 squared plus 84 squared plus 87 squared plus 93 squared. Okay, so I get 92,541. So it should be 92,541 over n. Now n, what do we say? How many pieces of data do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I think it was over 24. Minus, and then I'm going to go 1417 over 24. I'm going to square that, and then of course I need to get the standard deviation, I have to square root that whole thing. Okay, so let's do that. What do we get? 92,541 over 24 minus the what is it, that fraction, 1,417 over 24, and we're going to square that, and then we take the square root of that answer, and I'm getting 19.2. So 3 significant figures is the standard deviation. Alright, and of course we'll have probably talked about what that means in class. Okay, so that's the homework for week 1. Hope this makes sense. Let me know in the comments if you've got any questions or in ThinkWave, and I'm happy to help. Alright team, take care.